The Homi Bhabha National Institute is an Indian deemed university established by the Department of Atomic Energy, which unifies academic programs of several of its constituent institutions. Deemed universities in India have been divided in three categories by the Ministry of Human Resource Development, and HBNI has been placed in Category A, highest of the three categories. Homi Bhabha National Institute, Mumbai, and its constituent units are the institutions of excellence as per Section 4 of the Central Education Institutions Act, 2006. National Assessment and Accreditation Council has accredited HBNI with a CGPA of 3.40 on a 4-point scale at A and grade valid up to March 25, 2026. Early life and education. Homi Jahangir Bhabha was born into a prominent wealthy Parsi family, through which he was related to businessman Dinshaw Mainekji Petty. He was born on October 30, 1909. His father was Jahangir Hormusji Bhabha, a well-known Parsi lawyer, and his mother was Mahiran. He received his early studies at Bombay's Cathedral and John Connon School and entered Elphinstone College at age 15 after passing his senior Cambridge examination with honours. He then attended the Royal Institute of Science in 1927 before joining Caius College of Cambridge University. This was due to the insistence of his father and his uncle Dhirubji, who planned for Bhabha to obtain a degree in mechanical engineering from Cambridge and then return to India, where he would join the Tata Steel or Tata Steel Mills in Jamshedpur as a metallurgist. Further studies. Bhabha's father understood his son's predicament, and he along with his wife agreed to finance his studies in mathematics provided that he obtain first class on his mechanical sciences Tripos exam. Bhabha sat the Tripos exam in June 1930 and passed with first class honours. Meanwhile, he worked at the Cavendish Laboratory while working towards his PhD degree in theoretical physics. At the time, the laboratory was the center of a number of scientific breakthroughs. James Chadwick had discovered the neutron, John Cockcroft and Ernest Walton transmuted lithium with high-energy protons, and Patrick Blackett and Giuseppe Accialini used cloud chambers to demonstrate the production of electron pairs and showers by gamma radiation. During the 1931–1932 academic year, Bhabha was awarded the Salomon Studentship in Engineering. In 1932, he obtained his first class on his mathematical tripos and was awarded the Rouse Ball Travelling Studentship in Mathematics. During this time, nuclear physics was attracting the greatest minds, and it was one of the most significant emerging fields as compared to theoretical physics. The opposition towards theoretical physics attacked the field because it was lenient towards theories rather than proving natural phenomenon through experiments. Conducting experiments on particles which also released the enormous amounts of radiation, it was a lifelong passion of Bhabha, and his leading-edge research and experiments brought great laurels to Indian physicists who particularly switched their fields to the nuclear physics, one of the most notable being P.R. Singh Gill. Work in nuclear physics. In January 1933, Bhabha received his doctorate in nuclear physics after publishing his first scientific paper, The Absorption of Cosmic Radiation. In the paper, Bhabha offered an explanation of the absorption features and electron shower production in cosmic rays. The paper helped him win the Isaac Newton Studentship in 1934, which he held for the next 3 years. The following year, he completed his doctoral studies in theoretical physics under Ralph H. Fowler. During his studentship, he split his time working at Cambridge and with Niels Bohr in Copenhagen. In 1935, Bhabha published a paper in the Proceedings of the Royal Society, Series A, in which he performed the first calculation to determine the cross-section of electron-positron scattering. Electron-positron scattering was later named Bhabha scattering, in honor of his contributions in the field. In 1936, with Walter Heitler, he co-authored a paper, The Passage of Fast Electrons and the Theory of Cosmic Showers in the Proceedings of the Royal Society, Series A, in which they used their theory to describe how primary cosmic rays from outer space interact with the upper atmosphere to produce particles observed at the ground level. Bhabha and Hitler then made numerical estimates of the number of electrons in the cascade process at different altitudes for different electron initiation energies. The calculations agreed with the experimental observations of cosmic ray showers made by Bruno Rossi and Pierre-Victor Auger a few years before. Bhabha later concluded that observations of the properties of such particles would lead to the straightforward experimental verification of Albert Einstein's theory of relativity. In 1937, Bhabha was awarded the senior studentship of the 1851 exhibition, which helped him continue his work at Cambridge until the outbreak of World War II in 1939. Career. Starting his nuclear physics career in Britain, Bhabha had returned to India for his annual vacation before the start of World War II in September 1939. War prompted him to remain in India and he accepted a post of reader in physics at the Indian Institute of Science in Bengaluru, headed by Nobel laureate C.V. Raman. During this time, Bhabha played a key role in convincing the Congress Party's senior leaders, most notably Jawaharlal Nehru, who later served as India's first Prime Minister, to start the ambitious nuclear program. As part of this vision, Bhabha established the Cosmic Ray Research Unit at the Institute, began to work on the theory of point particles movement, while independently conducting research on nuclear weapons in 1944. In 1945, he established the Tata Institute of Fundamental Research in Bombay, and the Atomic Energy Commission in 1948, serving as its first chairman. In 1948, Nehru led the appointment of Bhabha as the director of the nuclear program and tasked Bhabha to develop the nuclear weapons soon after. In the 1950s, Bhabha represented India in IAEA conferences, and served as president of the United Nations Conference on the Peaceful Uses of Atomic Energy in Geneva, Switzerland in 1955. During this time, he intensified his lobbying for the development of nuclear weapons. Soon after the Sino-Indo War, Bhabha aggressively and publicly began to call for the nuclear weapons. Bhabha gained international prominence after deriving a correct expression for the probability of scattering positrons by electrons, a process now known as Bhabha scattering. His major contribution included his work on Compton scattering, R process, and furthermore the advancement of nuclear physics. He was awarded Padma Bhushan by Government of India in 1954. He later served as the member of the Indian Cabinet's Scientific Advisory Committee and provided the pivotal role to Vikram Sarabhai to set up the Indian National Committee for Space Research. In January 1966, Bhabha died in a plane crash near Mont Blanc, while heading to Vienna, Austria to attend a meeting of the International Atomic Energy Agency's Scientific Advisory Committee. Atomic energy in India. When Homi Bhabha was working at the Indian Institute of Science, there was no institute in India which had the necessary facilities for original work in nuclear physics, cosmic rays, high-energy physics, and other frontiers of knowledge in physics. This prompted him to send a proposal in March 1944 to the Sir Dorabji Tata Trust for establishing a vigorous school of research in fundamental physics. In his proposal he wrote, "There is at the moment in India no big school of research in the fundamental problems of physics, both theoretical and experimental. There are, however, scattered all over India competent workers who are not doing as good work as they would do if brought together in one place under proper direction. It is absolutely in the interest of India to have a vigorous school of research in fundamental physics, for such a school forms the spearhead of research not only in less advanced branches of physics but also in problems of immediate practical application in industry. If much of the applied research done in India today is disappointing or of very inferior quality, it is entirely due to the absence of sufficient number of outstanding pure research workers who would set the standard of good research and act on the directing boards in an advisory capacity. Moreover, when nuclear energy has been successfully applied for power production in say a couple of decades from now, India will not have to look abroad for its experts but will find them ready at hand. I do not think that anyone acquainted with scientific development in other countries would deny the need in India for such a school as I propose. The subjects on which research and advanced teaching would be done would be theoretical physics, especially on fundamental problems and with special reference to cosmic rays and nuclear physics, and experimental research on cosmic rays. It is neither possible nor desirable to separate nuclear physics from cosmic rays since the two are closely connected theoretically. The trustees of Sir Dhirubji Jamsetji, Tata Trust, decided to accept Bhabha's proposal and financial responsibility for starting the institute in April 1944. Bombay was chosen as the location as the government of Bombay showed interest in becoming a joint founder of the proposed institute. The institute, named Tata Institute of Fundamental Research, was inaugurated in 1945 in 540 square meters of hired space in an existing building. In 1948, the institute was moved into the old buildings of the Royal Yacht Club. When Bhabha realized that technology development for the atomic energy program could no longer be carried out within TIFR, he proposed to the government to build a new laboratory entirely devoted to this purpose. For this purpose, 1,200 acres of land was acquired at Trumbauti from the Bombay government. Thus the Atomic Energy Establishment Trumbauti started functioning in 1954. The same year the Department of Atomic Energy was also established. He represented India in international atomic energy forums, and as President of the United Nations Conference on the Peaceful Uses of Atomic Energy, in Geneva, Switzerland in 1955. He was elected a foreign honorary member of the American Academy of Arts and Sciences in 1958. Nuclear Power Program. Bhabha is generally acknowledged as the father of Indian nuclear power. Moreover, he is credited with formulating a strategy of focusing on extracting power from the country's vast thorium reserves rather than its meager uranium reserves. This thorium-focused strategy was in marked contrast to all other countries in the world. The approach proposed by Bhabha to achieve this strategic objective became India's three-stage nuclear power program. Bhabha paraphrased the three-stage approach as follows: the total reserves of thorium in India amount to over 500,000 tons in the readily extractable form, while the known reserves of uranium are less than a tenth of this. The aim of long-range atomic power program in India must therefore be to base the nuclear power generation as soon as possible on thorium rather than uranium. The first generation of atomic power stations based on natural uranium can only be used to start off an atomic power program. The plutonium produced by the first-generation power stations can be used in a second generation of power stations designed to produce electric power and convert thorium into U-233, or depleted uranium into more plutonium with breeding gain. The second generation of power stations may be regarded as an intermediate step for the breeder power stations of the third generation, all of which would produce more U-238 than they burn in the course of producing power. Death. Bhabha died when Air India Flight 101 crashed near Mont Blanc on January 24, 1966. A misunderstanding between Geneva Airport and the pilot about the aircraft position near the mountain is the official reason of the crash. Assassination claims. Many possible theories have been advanced for the air crash, including a claim the Central Intelligence Agency was involved in order to paralyze India's nuclear program. An Indian diplomatic bag containing calendars and a personal letter was recovered near the crash site in 2012. Gregory Douglas, a journalist who conducted telephone conversations with former CIA operative Robert Crowley for 4 years, published a book called Conversations with the Crow. Douglas claims that Crowley implied the CIA was responsible for assassinating Homi Bhabha, as well as Indian Prime Minister Lal Bahadur Shastri in 1966, 13 days apart, with the intention of thwarting India's nuclear program. Crowley reportedly said that a bomb in the cargo section of the plane exploded mid-air, bringing down the commercial Boeing 707 airliner in Alps with few traces, saying, "We could have blown it up over Vienna, but we decided the high mountains were much better for the bits and pieces to come down on." Legacy. After his death, the atomic energy establishment at Mumbai was renamed as the Bhabha Atomic Research Centre in his honour. In addition to being an able scientist and administrator, Bhabha was also a painter and a classical music and opera enthusiast, besides being an amateur botanist. He is one of the most prominent scientists that India has ever had. Bhabha also encouraged research in electronics, space science, radio astronomy, and microbiology. The famed radio telescope in Oadhi, India was his initiative, and it became a reality in 1970. The Homi Bhabha Fellowship Council has been giving Homi Bhabha Fellowships since 1967. Other noted institutions in his name are the Homi Bhabha National Institute, an Indian-deemed university, and the Homi Bhabha Centre for Science Education, Mumbai, India. At Bhabha's death, his estate, including Maranger, the sprawling colonial bungalow at Malabar Hill where he spent most of his life, was inherited by his brother Jamshed Bhabha. Jamshed, an avid patron of arts and culture, bequeathed the bungalow and its contents to the National Centre for the Performing Arts, which auctioned the property for Rs 372 crores in 2014 to raise funds for upkeep and development of the centre. The bungalow was demolished in June 2016 by the owner, Smita Krishna Godrej of the Godrej family, despite some efforts to have it preserved as a memorial to Homi Bhabha. In popular culture, Rocket Boys is a web series inspired by the lives of Homi J. Bhabha, Vikram Sarabhai, and APJ Abdul Kalam.